Hello, ndikulandireni pamene tikupitiriza phunziro lathu la graphs of quadratic functions. Ndipo lero tili mu lesson 4 tikupitiriza ndi interpreting graphs of quadratic functions. Mwanthawi zonse muli ndine Cicero Juma. So let's look at the effect of adding. The effect of adding or subtracting a constant from x and then squaring the result. In this case, let's look at this example. Y is equal to, in bracket, x minus 1 close bracket squared. In this case, we have a constant 1 which is being subtracted from x. Then if we square that, we are going to draw a graph and see how does it behave. The same way, if we add a constant 2 and we square it, it will then we're going to draw and see what the graph imaoneka bwanji. So the whole idea is to see what the quadratic graphs tikapanga quadratic graphs osiyana-siyana malinga ndi mmene tapatsidwira tikajambula amaoneka bwanji. Okay, so with this understanding ilithandizira kwambiri kuti tizitha kupanga sketch ma quadratic graphs of any given quadratic function. So in this case, for us to achieve this, we need to draw these three quadratic graphs. Y is equal to x squared, then y is equal to, here we don't have x squared in this scenario. Mukaipanga expand this function, it will be a quadratic function. The same applies to that one. So we are going to draw all these graphs all these functions per graph emoji, which is ranging whose x values are ranging from -4 to +4. So in this chimene chachikulu tikufuna kuona, tikufuna tuunikire kuti similarities kapena zimafanana bwanji. This is a standard one, then these are improved ones. So tikazijambula pa graph imodzi tiona kuti kodi this one, how is it behaving against that one, and the same applies to this one, how is it behaving against that one. So we also look at line of symmetry. These are important properties of quadratic functions which we need to understand pamene tikupanga izizo. Then we are also going to look at effect of adding or subtracting a constant from x and then squaring the results. Okay, so that's another thing imene tikuyenera tichike m'maganizo mwathu kuti chichitike ndi chani to this standard quadratic function when we subtract a value from x, then the result is squared. The same applies to that. Okay, so as shown from the previous slide, we have three functions where we have a standard one, y is equal to x squared, then y is equal to x minus 1. 1 is a constant, then the result squared, y, then the other function is where we are saying y is equal to, open bracket, x plus 2. 2 is a constant, then the result squared. So for us to draw this function on a graph, we need to come up with table of values. So for us to come up with a table of values, we have been doing that in the past lessons. So I'll not take much time on this one. I'll just show you the first one. The other ones, I'll do them myself. So we have x, we have y values. Remember, x values have to run from -4 to 4. Okay, and so when it's -4, what is the value of y? So it will be -4 in bracket squared, that will give you 16. -3 squared, that will give you 9. -2 squared, that will give you 4. -1 squared, that will give you 1. 0 squared is 0. 1 squared 1, 4, 9, and 16. Okay, and the table of values for this. So when in this case when x is minus 4, if we put there, it will be minus 4 minus 1, that's minus 5. Minus 5 squared, that will be 25. Same there, minus 3 minus 1, that will be minus 4. Minus 4 squared, that will be 16. That will be minus 2 minus 3. That will be minus 3 minus 3 squared, that will be 9. So that will be 9. Then minus 2 minus 1 minus 2. Minus 1 minus 1. That will give us, negative 1. We put it where the x is. If we subtract 1, it will be negative 2 squared. That will give you 4. There, it will be, not 0. Sorry, it will be 0 minus 1. That will give us negative 1. Negative 1 squared, it will give us 1. Then when it's 1 minus 1, it will be 0. So there will be 0. 2 minus 1, that will be 1. 1 squared, that will give us 1. And 3 minus 1, that will give us 2. 2 squared, that will give you 4. Then when it's 4, when x is equal to 4, if we subtract 1, it will give us 3, and 3 squared, it will give you 9. Okay, so to the second one, in this case, we're adding. So it will be minus 4 plus 2. It will be minus 2. So minus 2 squared, it will give you, minus 2 squared, it will give you 4. Those two give you 4, but plus 4. Minus 3 plus 2, it will give you minus 1. Minus 1 squared, it will be 1. Okay, then minus 2 plus 2, it will give you 0. 0 squared, give you 0. When it's minus 1 plus 2, it will give you 1. 1 squared will be 1. 0 plus 2, it will give you 2. 2 squared, that's 4. The same 1 plus x, when x is 1, it will be 1 plus 3, plus 2, which gives you 3. 3 squared, that's 9. The same applies there. 2 plus 2, 4. 4 squared, 16. Okay, then 3 plus 2, that's 5. 5 squared, that's 25. 4 plus 2, that's 6. 6 squared, that's 36. Okay, so here we have the table of values. What is now remaining is for us to come up with the, we have to draw these graphs on the right hand side. So for us to draw that, let's put up this plane. This is a Cartesian plane. No negative on the y side, so we can as well just do it like that. So this is x, this is y. Now we have this Cartesian plane, y-axis and x-axis, and it's a 2, 2 on the y-axis and 0.5 on the x-axis. That's the scale. So let's plot the first one. When x is minus 4, y is 16. When x minus 4, y is giving us 16. So let's put there. Okay. When x is minus 3, y is 9. So minus 3, that's 8. That's 10, which means 9 is between 10 and 8. So 9 is here. What's there? when it's 2, y is, when it's minus 2, y is 4. Y is 4. So, yeah. And when x is minus 1, y is 1. So this is 2, 1, which means it's between 0. There is 2, 3, 4. Is 2, so 1 is between 2 and 0. So it's here. It's there. Somewhere there. And when x is equal to 0, y is also 0. So this is somewhere there. And when y is equal to 1, I mean when x is equal to 1, that is xy. Y is also is also 1. So it means it's between there. So, yeah. And when x is 2, y is equal to 4. So x2, y 4. So it's there. Okay. When x is 3, y is 9. So 9 is between 8 and 10. This is 10. So 8, 9 is here. Okay, it's there. It's between there. Somewhere there. When when x is equal to 4, y is equal to 16. So that's 16. Okay, so let's try to plot. Let's try to plot this. So let's plot this. Okay, so plotting on this device is not easy, but I'll try. Okay, so yeah, so just like that. So this is more like a plot. It's going like that. We can, yeah. So something like that, and this is what we're calling y is equal to x squared. So let's now plot. Y is equal to x minus 1. That is that squared. So in this case, we are saying when x is minus 4, y is equal to 25. So we have 24, and there is 26, 25. It's between 26 and 24. So that's 4. This is 24. That's 26. So 25. It's here. Okay. And when y is minus 3, x is 16. So minus 3. Where is our 16? That's, I mean, when x is minus 3, y is 16. So that's minus 3x. Y 16 is here. And when x is minus 2, y is equal to 9. So this is 8, this is 10. We have 8 here. 8. That's 10, which means 9 is between 8 and 10. It's somewhere there. Okay, and when x is minus 1, y is saying is minus, it's positive 4. X minus 1, positive 4, so it's somewhere here. Okay, and when x is 0, y is 1. X is 0 here, y is 1. Y is 1. This is 2. 1 is above, just above here. Okay, and when x is 1, y is 0. So y0 is there. Okay, when x is 2, y is equal to 1. So y is equal to 1. 1 is here. Okay, when x is 3, y is equal to 4. So where is our 4? This is our 4. When x is equal to 4, y is equal to 9. So where is our 9? This is our 8. And our 9 is in between 10 and 8. So that's where our 9 is. Okay, now let us try as well to plot this one. Okay, so let's start all over. Try. Okay, so it's going like that, like that, and it's proceeding there. So this is y is equal to x minus 1 in bracket squared. And we are beginning with one graph, which is, whose the table of values are the following. Whose table of values are the following. This is x plus 2 in bracket squared. So let's also plot it on the same graph. Okay, so when x is minus 4, y is 4. When x is minus 4, y is 4. So it's here. 4 is there. When x is minus 3, y is 1. So where is 1? 1 is between, this is 0, this is 2. So 1 is between 0 and 2. So it's here. Right. Somewhere there. When x is minus 2, y is equal to 0. So 0 is here now. Okay, that's where y is equal to 0 is. When x is minus 1, y is equal to positive 1. When x is minus 1, y is equal to positive 1. So that's where our positive 1 is. Still there, somewhere there, yeah. And when x is equal to 0, y is equal to 4. So x is equal to 0, y is equal to 4. Okay, and when x is equal to 1, y is equal to 9. So where is 9? This is 8. This is 10. 9 is between 8 and 10. Okay, when x is equal to 2, y is equal to 16. So let's go where 16 is. So that's our 16. And when x is equal to 3, y is equal to 25. So where is 25? This is 24, and this is 26. 25 is between 24 and 26, so it's there. When x is equal to 4, y is equal to 36. So this is our 36. Okay, so let's do this. Here, tukozesa obidiriza kuti kale buno bwino parabola obo. Okay, kale buno bwino here. Yeah. So this one we know. This one is y is equal to x minus, plus 2 squared. Okay, x plus 2 squared. All right. Yeah, so now we have 3 graphs put together on the same graph. Pano tuone interpretation ya zimene zikuchitika pa magraph athu onse atatu amene tajambula. Graph yoyambayi, we are saying in this case let's have this. We have y is equal to x minus 1, and this is the graph of y is equal to x minus 1. If you look at it, it has the same shape as this graph. And that graph, the graph of y is equal to x squared, which is also a standard one. It has the same shape. The only difference, tangoipanga shift graph imeneyi by 1 unit, okay, by 1 kubwera to the right hand side. Okay, to the right hand side we have just shifted it by 1, and that 1 should see ikufanana the constant here. Okay, which means if you take away 1, if there is no 1, if there is no this constant, or if this constant is 0, it means it will be x squared. It means it will remain at the origin. Okay, so this y is equal to x squared is turning at the origin, but this one is turning at x is equal to 1 and y is equal to 0 at this point, which means it has been shifted to the right by 1 unit. Pomwe graph imene tikuitcha kuti y is equal to open bracket x plus 2 close bracket squared. In this case we are adding a constant. So pamene tikupanga add constant, we see kuti shape ndi yomweyi imene ili ndi y is equal to x squared, but we have shifted it towards the left by 2 units. In this case by 2. Okay, tangoyisuntha kuchibweretsa kumanzereku by 2. Okay, so those are the things zimene mukuyenera muzisunge. Tikamaphatikiza constant, we shift the graph. If it has that form, we shift it to the left hand side. When we are subtracting, we shift it to the right hand side. Okay, now even if you look at the line of symmetry, for y is equal to x squared, the line of symmetry is this one. Okay, the line of symmetry is this one. It's at 0. It's at x is equal to 0. And for this one, the line of symmetry has also changed. It's at the line of symmetry is at x is equal to 1. While this one, the line of symmetry is at x is equal to negative 2. So even the line of symmetry has changed. The minimum value of each function is 0. Okay, so you see that the minimum value here, if we run across the x-axis line, which is 0. Okay, which is y is equal to 0. So that's the minimum. That's the minimum. And the square of the constant gives a y-intercept. Okay, so this is a constant. If you square it, for example, in this case, if you square it, it will give you 4. And that 4, you see that it's where it's cutting the y-intercept. Even if you square minus 1, you see that the value at the point at which it is cutting y-axis is also at point 1. Okay, so those are the things that you need to keep in this. All right, so once again, pamene mukuphatikiza constant, you shift the graph, this is standard graph, by that constant, by that value to the left hand side. When you are subtracting, you shift it by the value of the constant to the right hand side. And bear in mind, the line of symmetry also changes from 0 to the value of the constant, and from 0 to the value of the constant. And also note that the square of that constant, if you square that constant, it will be the point at which your graph will cut the y-axis. In this case, if you square minus 1, you will find out it's 1. So you see that your graph, this graph is cutting y-axis at 1. If you square minus 2, it will be positive 4. You'll see that it's cutting your y-axis at 0.4. Okay, so for interpretation, keep that. Pano tione conclusion. In conclusion, tukunena kuti if you add a constant to x, Okay, you have this standard quadratic function. Now if you add a constant to x, then put them in a bracket, then square the result, what will happen is you are shifting this graph. Okay, you are shifting this graph to the left. You are shifting it to the left hand side by the value of the constants. In this case, you add minus. Okay, and if you are subtracting a constant from x before squaring it, it shifts the graph. Okay, it shifts that graph, which is at the origin, which is a standard graph, towards the right hand side by the value of positive constant that we have been given. And you have to understand that the minus constant and the plus constant are also the new lines of symmetry. Takambapo zimenezo, this constant, these constants become the new line of symmetry. Okay, in this case here the new line of symmetry is x is equal to 1, and here the new line of symmetry is x is equal to -2, and the y-intercept, there's also the photogosa, the y-intercept, the point at which your graph cuts y-axis, is the same as the square of the constant that you are either subtracting or adding. In this case, this is your constant, which is 2. If you square 2, it's 4. So it will cut at 4. In this case, our constant is 1. If you square 1, you find out it's 1. So it's cutting y-axis at 1. So reaching this far, let's stop there. So lesson in next time we meet. Have a good day. Thank you.